Welcome to the VeraGrid Feature Spotlight series. In this series, we'll dive into the core features and powerful capabilities of VeraGrid, our state-of-the-art open source platform for modern power analysis. Each episode of this series will showcase a key functionality within VeraGrid, highlighting how it can help streamline grid modeling, accelerate studies, and unlock new insights from your data. Whether you're a student just beginning your journey in power systems, or a seasoned professional looking to enhance your workflow, these tutorials are designed to make advanced grid analytics more intuitive, flexible, and accessible to everyone. In this first video, we'll take you on a tour of the user interface and modeling philosophy behind VeraGrid. We've put huge effort into making VeraGrid simple, elegant, and powerful, so you can focus on what matters most, understanding and improving your power grid. Let's start by building a schematic. In VeraGrid, you can begin adding buses simply by dragging and dropping them from the menu on the left into the schematic canvas on the right. Once you place a bus, it's immediately created in your model. Now, let's add a second bus, and then connect them by clicking and dragging from the first bus to the second. This will by default create a line object connected from bus 0 to bus 1. If we right-click on the line object we just created, the line menu will pop up. In this menu, we can transform the line into other kind of branches, such as HVDC lines, transformers, and VSC converters. Likewise, if we right-click on a bus, the bus menu will pop up. In this menu, we can perform a number of actions on the bus. Most importantly, we can add injection devices such as loads, generators, batteries, and shunts, change the bus type from AC to DC, and activate or deactivate the bus. Whenever we click on an object in the schematic, a table with the object properties is displayed on the left. In this table, we can edit most of the object's properties. Some properties are editable, like the bus nominal voltage, and others are not, like the connection buses of a line object. This is to preserve model integrity by preventing accidental changes to the model's connectivity. In order to automate the schematic creation process, any line between an AC and DC bus will automatically be created as a converter, and any line between two buses of different voltage will automatically create a transformer. For grids that have coordinates defined, there is also the option to view the model in map view. We will look deeper into defining the coordinates in a future video. The Database tab view is an alternative way of defining and modifying the objects of the model. In VeraGrid, there are two main data constructs, the snapshot and the time series. Snapshots represent a single time, generally an hour, and serves as an equivalent format for single-hour models from commercial software like PSSE RAW or from interchange standards such as CGMES. The time series represent variations on parameters that can change over time, such as the active power of a generator or load. These values may be imported from spreadsheets, CSV files, or come from combining many operational snapshots. In the Objects view, we can see the snapshot. On the left, we have a list of the types of model objects that can be edited. On the right, we have a table containing all the editable and non-editable properties of the objects of the selected type. In the table, we can just enter values for the properties and they will immediately update the internal values. The values of an entire column can also be changed at once for speed, and at the top and bottom of the table, you will find functions to modify and filter the data. Templates in VeraGrid are objects that define a generic device. For instance, a certain transformer or line type could be defined once as a template and reused many times. This tremendously simplifies the data entry process. All the values of the templates can be modified in the table, though some templates have their own specific editor, for example, the overhead line. This is the time series view. All the variables that vary with time are stored in the time series. The time series stores load profiles, generation profiles, rating profiles, and many others. In this view, we have all the functionality to format the model profiles, import data, set simulation ranges, and even set a snapshot view from a particular time series event. The time events do not need to have evenly separated intervals. Their time separation can be anything. However, the default formatter will generate evenly separated time events. The compiled arrays view allows you to visualize the number of topological islands present in the snapshot. It also lets you visualize many of the numerical matrices and vectors used in calculation routines. You can export all of these at once inside a zip file for later investigation. This view helps with debugging new numerical methods and diagnosing non-functioning models. The comments editor is a simple text box where you can write notes or comments about your project. It's a convenient way to keep track of decisions, reminders, and important context right inside your model file. The results view allows you to access all the results from the simulations that have been executed. On the left, there is a tree view with the simulation types and their available results, like voltage, branch loading, and more. On the right, there is a table view where the values are displayed. Once a result is selected, it can be plotted, copied to the clipboard, or saved as a table. The results can also be saved and loaded into the current VeraGrid file. This is an incredibly useful feature that allows you to share the model along with the exact simulation results you obtained. In the VeraGrid user interface, only one set of results is allowed per simulation type, but this can be avoided by using VeraGrid in library mode. In addition to the simulation results, a log of the simulations can also be viewed in the log tab. VeraGrid also includes a built-in Python console, a powerful addition that allows you to add a layer of automation directly within the graphical user interface. This console is a fully functional Python environment embedded inside VeraGrid, and it gives you access to the circuit you've created in the interface. You can run any Python command or operation you would normally execute in your scripts, all without leaving the app. The Settings tab contains all the parameters that can be tweaked for each type of simulation. By default, VeraGrid has parameter settings that are effective for most cases, but you may change them as required. More sophisticated simulation workflows can be achieved by using VeraGrid in library mode. All the settings and parameters will be explained in specific videos. That wraps up this feature spotlight. If you have any questions or run into something you'd like clarified, feel free to leave a comment below. Check out our documentation or reach out to us directly on Discord. We're always happy to help. We'd also love to see what you build with VeraGrid, so don't hesitate to share your projects or results with us through the contact links in the description. And finally, if there's a feature you'd like to see added, consider contributing to the project. Your ideas and feedback play a big role in shaping the future of VeraGrid. Thanks for watching, and see you in the next video.